This is a chemistry video. It's an introduction to stoichiometry. I'm going to introduce the subject and I'm going to show you an example of mole-to-mole stoichiometric conversions. If you want more complicated stuff, I'm sure there will eventually be a link in the description to the next video. Stoichiometry, what is it? Well, it's a study of quantitative relationships between amounts of reactants used and products formed by a chemical reaction. Big word there, quantitative. Kind of looks like the word quantity. Quantity is always a numerical amount. It's a count, it's a number of things. This comes about from the law of conservation of mass. Stoichiometry is kind of the study of saying that the total mass of the reactants equals the total mass of the products. Observations made of many reactions for a long period of time, hundreds of years, have shown that whenever you do a chemical reaction, no atoms are created, no atoms are destroyed. They just rearrange, they bond differently after the reaction than they did before, so the total mass of all the stuff remains the same. Here's the basics. Hydrogen plus oxygen gives us water. This is going to be our sample reaction. The 2 in front of the hydrogen means that there are 2 molecules of hydrogen. There's no number in front of the oxygen, so that means there's 1 molecule of oxygen. And there's 2 in front of the water here, the H2O, means there's 2 molecules of water formed. And the G's after each thing mean gas. So let's say I wanted to know how many moles of water I can produce from 4 moles of hydrogen. Don't worry about the amount of oxygen. If we needed to know that, it would tell us. And if you're learning this, eventually you'll get to the point where it does give you amounts of both. But for now, don't worry about it. Pretend that you have all the oxygen you could ever need. Here's how we're going to do it. I'm going to write down the amount of hydrogen that I have, that's 4 moles. Then I'm going to build myself a conversion factor from the numbers in the reaction. See, there's a 2 in front of the H2. That means that there are 2 moles of hydrogen used in the reaction. There's a 2 in front of the H2O. That means there are 2 moles of water produced in the reaction. I'm putting the hydrogen in the denominator and the water in the numerator because I want to get rid of the hydrogen and I want the water. Since I start out with hydrogen, I divide by hydrogen. Moles of H2 cross out. You're left with moles of H2O. 4 times the 2 in the top gives me 8, divided by the 2 in the bottom gives me 4 moles of H2O. If that's confusing, if you don't like it that way, try this way. Start off with my 4 moles of H2, and instead of writing out that fraction, first let's draw a horizontal line, then let's draw a vertical line. Now again, I want to get rid of moles of H2, so let's put moles of H2 on the bottom. Put the 2 in front of the moles of H2 because that's the number next to H2 in the reaction. Always use the numbers in front of each chemical formula. Those are the coefficients. Don't mess with the numbers after each letter in the formula. Those subscripts tell you how many of each atom there are. Alright, so I got the moles of hydrogen in the denominator. That's going to divide out. I'm going to put moles of water in the numerator because that's what I want. Again, hydrogen divides out, I'm left with moles of water. Do the math, and you get 4 moles of H2O. If you write it out like this, take your starting number here, multiply it by whatever is above the middle line, and divide by whatever is below the middle line. I suggest you do them one at a time. First do 4 times 2, put in your calculator if you need to, hit equals, then divide by 2. There's your answer. Let's do another one. How many moles of water can be produced from 4 moles of oxygen? Notice that I'm starting from the other reactant this time. It's going to give me a slightly different answer. We'll write it out like this. 4 moles of oxygen is what I start with. Then I'll build my fraction again. In the reaction, there's no coefficient in front of the O2. That means that it's got to be a 1. So I write 1 mole of O2 in the denominator. 2 moles of H2O, because again, there's a 2 in front of the H2O. Multiply. 4 times 2 is 8. Divided by 1, still 8. If you want to do it the other way, write the 4 moles of O2, draw the horizontal line, draw the vertical line, write 1 mole of O2 in the denominator because you want the moles of oxygen to cancel. Write 2 moles of H2O in the numerator. Oh, forgot to write the O. Put an equal sign and do the multiplying. 4 times 2 is 8, divided by 1 is still 8. There you go. That's the basics of stoichiometry. We'll do a more complicated problem later. If you watch this, thank you. I appreciate it. If you want more, please subscribe. And I hope that helped you out. Let me know if it did. And if you have any questions in the comments, I'll even answer once I notice it's there. Take care, and bye for now.